Uh, would like to thank Chitra for kind introduction. Appreciate that. Um, so again, it's a pleasure to be part of ACMW India annual summit that's happening. Yeah. ACMW India Summit that is happening, this ACM annual event here in Coimbatore 2025. I was kind of thinking of doing a little bit of disruption here. Can I ask a question to the audience? How many of you are graduate students pursuing masters or PhD? Can you please raise your hands? Thank you. And how many of you are undergrad students? Great, great. Yeah, thank you. Is it done? All right. So today I'm wearing two different hats. One hat is the ACMW Global Leadership Team's chair for regional activities. And the second hat that I'm wearing today is of a scientist, of a teaching associate professor doing some work in national defense sector and sharing my experiences in that field of expertise. So we'll be toggling that hat in between and might skip few slides here and there just to kind of convey what I'm trying to convey. So let me first start with the ACMW. I'm sure, Ruth, you might have introduced about ACMW. It is a body underneath ACM which kind of advocates participation of women in computing. So I'm sure you might have this question from your mind that, is it something feminist movement? Why do you want to have a special thing for women? So I would love to share this analogy with you. Say all of us are marathoners. So our ultimate goal is what? To finish the marathon, right? And with a very good standard of completion. Now assume that one of your leg is injured and you're walking like a little bit clumpy. So in that case, would you take care of your leg and finish the marathon, or you'll put it on the side for some time and complete the marathon and then take care of it later on? Option A or option B? Take care of that right now, or option B is finish the marathon, because anyways you can finish, right? Doing this way. You'll finish the marathon and complete the race. So what option is better, A or B? Is it a very difficult question? Option 2, right? Yeah. So option 2 makes sense, that if we really take care of the leg that is limping, we can have a better quality of completion of marathon, right? So the same thing happens in the field of computing. If we have only input coming from one sector, one gender, it would definitely introduce some bias in our understanding, bias in the processes, bias in the systems that are being developed, and therefore we probably need to have something done to support, encourage and motivate women to participate in computing, right? And that is why we have this ACMW wing. So I wouldn't be talking about India projects, but I'll just kind of quickly talk about the W global efforts. So you are able to see this presence of ACMW chapters across the globe. There are roughly about 200 odd chapters, which are student chapters or the professional chapters, and they are sitting at different regions, as you see here. So the ACMW at the global level has got specifically assigned regions, and the different regions that we work on are the ACMW North America, which you see here on the left, then the ACMW Europe, ACMW India, and ACMW Asia Pacific. So these are the different regions that we have committees, and they work in these regions to support participation of women in those regions or areas geographically. And what is nicely done is the North America team is helping out the South American efforts here. They are mentoring the South American efforts. And then the same thing is seen in Europe. They are helping out the African region ACMW chapters and ACMW activities. And ACM India is kind of its own chapter because it's supported by ACM. W India is supported by ACM India. And this is the Asia Pacific region that we have. So these are different regions in which ACMW works. And apart from all different projects which Ruthvi might have introduced today in the beginning of ACMW's session, what I would like to advocate today is just one project, and that is the ACMW Buddy System or Buddy Project. So what we are trying to appeal or encourage is to have interaction or to have a companionship between two different ACMW chapters. Bless you. So, two different ACMW chapters from different regions. And you can also appeal companionship with other ACM chapters, sub-SIG chapters or ACM chapters. I mean, that is also fine. And kind of have some kind of ongoing relationship with those chapters. So here, as we see, we have different natures of the chapters. You can think of, say, this is my ACMW chapter. You can have the ACM local buddy. Local buddy is somebody from your city or your kind of neighboring geographical region where you can reach frequently and have some ongoing projects together as a single unit. Then you can think of somebody as a country buddy. Country buddy, that is having companionship with some other ACM chapter from within the same country, right? The third one is region buddies. In all those different 4 regions which I showed, can have some chapter in these regions and have association with them. And the fourth one is global buddies, somebody other than or outside our own region, right? So why to do this? The reason behind appealing for this kind of project is so that we can have more global awareness, we can have interaction with different chapters across the globe and try to kind of understand more from them. So next question, what can I do with them? Yes, you can do all different kind of activities like 101 activities for ACMW or 101 activities for chapters. You can do anything from that. Could be a simple thing, you're reading a Harry Potter book together once a week or once a month, something like that. Or you're having some paper reading sessions going on between different chapters collaboratively. Something like that can also be done, right? Or to put an example or exemplar here, the ACMW chapter from Turkey and ACMW chapter from Ireland, they had a ACMW buddy project done together. They worked on reading research papers together in the field of XYZ. I'm not exactly remembering the field, but then what happened after a collaboration of 1 year, they came up with a poster presentation during the Women Encourage 2024. So that poster was presented as a collaborative effort between the members from these 2 chapters sitting far away from each other. So something like this can be done. Now, also I would like to appeal students, how many of you are ACM student chapter members or ACM members, student members? Can I see hands raised? Okay, few of you, great. So I'm kind of tempted to put forward the thought or the quotation by Nandan Nilekani. I'm sure each one of us know who he is, right? Co-founder of Infosys and also one of the contributors for Aadhaar card. So he said that studying at IIT Bombay, yes, it's definitely great in the classrooms and all, no doubt about that. But the most thing that impacted in building his character, which helped him building Infosys or other projects, was to participate in the local activities like Mood Indigo. He was one of the active contributors while he stayed in IIT Bombay. Right? So we might want to think that, do we really want to spend some time and try to learn, try to understand how we can support in non-selfish efforts that happen across on the campus or in the society around us, right? So this is what I would like to talk about the ACM and ACMW efforts. Yeah. So, okay. Now I am removing that ACMW leadership team hat and I am putting on my researcher's hat. Okay. So I was thinking about what would be the best topic to talk for this kind of platform where we have a mixed community of students from undergrad and postgrad levels. And second thing is, because of my research work, which has been associated with the defense organizations, some of the work I have never published till now, and some of the work I cannot talk about. So I will try to speak in cryptic language, where I'm really not expressing everything what I have been doing, right? So I would take an exemplar of this reliability of unmanned ground vehicle network when I talk about these different technologies that I'm trying to discuss. So let me come down and put what I'm thinking. So generally, if you look at the situation around us, the global situation, there are a lot of ups and downs happening in the global scenario because of the association between the different countries with different projects and so on, right? So how can we come up as an expert player? How can we dominate in this field? How can we be superpower in this field for any nation would depend on what kind of technologies we are supporting and how strong we are in those technologies. Great. Now, who decides what technologies are the ones that really impact innovation in the technical field? So there are few few sources, like for example, the documents from different federal government agencies, the document driven or generated by the White House, talking about the technological and innovation, the top technologies that impact society today, and so on. So I would like to take help of those documents and kind of have my talk within that arena. So this is what I was talking about, the reliability of unmanned ground vehicles. The problem is we have a convoy of unmanned ground vehicles which are moving on the ground, and this work was done with Tank Automotive Division of US Army at Arati in the US. So we have this group of unmanned vehicles, and we are trying to move these vehicles in a very different terrain, and not sure how the terrain would be. A lot of uncertainties involved in there, weather and so on. And how can we say that, okay, this is a perfect thing? Can I have quantitative measurement of the reliability of vehicles that are being arranged on the ground? So that is what we are trying to understand, right? And for quantitative assessment, we are measuring something called as reliability of unmanned ground vehicles as a whole unit together, so as to support collaboration and coordination between these vehicles on the ground. And second thing is, I also want to know, say I'm moving one vehicle from point A to point B, what is the probability of success? Success is measured between 0 and 1. This is what we are trying to do. Okay. So let me, with that, move on to the critical and emerging technologies list. So these are the list, or this is the list that is put forth by a report by a fast track action subcommittee on science and technology of the National Science and Technology Council, the Office of Science and Technology Policy. And they come up with this kind of list every year, which is kind of very abstract, right? They say artificial intelligence or hypersonics and so on, right? They are very abstract and at very, very high level. So these are few areas like advanced computing, advanced network sensing and signature management, AI, or data privacy, data security and cyber security technologies, and so on. They are kind of technologies of interest for community like us that we have here. Okay, so now in that list of technologies, the next question is, how do we really take up or think about top 10 emerging technologies for defense or for national security? So an effort was done by a team at Booz Allen, which are defense consultants and consulting company. So what they kind of incorporated was, they took up the reports from the different federal agencies. They also took into account the experts' opinion, like SMEs, subject matter experts. They took into account the defense agencies and technological watch lists, information and opinion on what technologies matter the most, and they kind of come up with a list. of top 10 technologies. See, for example, as we saw that on the previous list, there was something called as trusted AI and trusted AI, say for example, in autonomy. So this is very broad area, right? So in this also, how can we really subcategorize to technologies that really matter us most, and we can kind of correlate with them, like multimodal AI or artificial general intelligence, or something like swarms and so on. So in this way, taking into account different factors like what is market momentum, what is defense implementation speed, what is the technological relevance that we have here, and so on. So taking into account different constraints, the list was shortlisted, and the down criteria selection also included something like defense impact, then technological readiness level, then commercial impact, and so on. So all these things are were taken into account. And something that really appealed me personally was they also took into account the funding that is and the startups in this different technological areas. How are these startups affected, or what are these startups doing? What is the funding received by these startups? So generally, as an academic researcher, it is my tendency that I typically go and refer to some research papers, right? Mostly. So here is an appeal that yes, we can go to something like PitchBook and so on, and look at what is happening in the funding side of the problem. How is that working? And second thing I would also like to highlight here is typically we think that yes, the initial research was started by the defense agencies on the West Coast, Silicon Valley of US, right? And that was supported by the defense community. Then after some time, if we look at the status of that, most of the innovation is being done by the private sector right now. And it is seen that there is good collaboration that is happening between the private sector and the defense organizations, defense federal agencies, and so on. So in this today's day and age, it is best to have this kind of collaboration seen that is happening between the defense and the private sector. And that is the way to go forward. Just to share an example, Air Force was trying to optimize the fuel consumption that was happening on their different airplanes last year sometime. So they realized that instead of reinventing the wheel and trying to find out the mechanism of optimizing the fuel consumption in the airplanes, they kind of partnered with the commercial airline agencies and used their expertise, because they are running this day in and out, and they came up with a solution that really is viable for defense to kind of have optimization of the fuel that is being used on different airplanes. So that is one example. And yeah. So another reason for the technologies to select for today's talk was to take into account the different situations that we see around us. Say in 2019, around 2020 or so on, Azerbaijan had this war with Armenia, and they came out as a successful kind of winners. So what was that? Did they really fight on the ground? No, it was actually a technological war, and that was mostly dominated by the drones and the technology that was used there, right? If you look at the Ukraine war right now, what's happening is, how can we imagine to have them creating a level play field with Russia to kind of have this fight going on, right? So one of the noticing thing that I found here is that they use technology to their advantage. They use drones, they use AI heavily, and because of that, they're at least able to create a level field with the Russian, or with their enemy encounters. So these are the top 10 emerging technologies which this team think is really or plays a meaningful role in changing the influencing the way cyber warfield is managed, and influencing the way in which it can turn out or come up with be a superpower in this fight. So these are different areas, as you see on the screen here: AI accelerator chips, alternative position and navigation and timing systems, and so on. So what I'll do is I'll go through each one of them quickly, and I'll try to see and talk about what different work I've been involved in these areas. So for this, something that is neatly used is the radar charts and investment charts, as you see on the screen here. On the left are the radar charts, and we have here five constraints or five properties that are of interest for us. They are TRL, commercial impact, market momentum, defense impact, and defense implementation speed. So here, number one is the lowest. It means it needs a lot of work still in that area, or it's still lagging. And number five is the strongest. It's pretty much ready and ready to go, and we have kind of done good job in that. So readiness is like the orange is low and green is high. And if you look at the investment charts, these charts, they show the investment that has happened in these different areas of research or technological areas. And the short forms are IPO is for initial public offering, M&A is for mergers and acquisitions, PIPE is for private investment in public equity, and VC is venture capital, and so on. And for this, mostly we have been referring page book for finding out the information about these facts on the investment charts. But by no means they are very accurate. There is some kind of extrapolation being done here. So there is a room of some kind of few things, a few errors here and there in this investment charts for each technological area. So the first area is AI accelerator chips. So in this area, basically what we are looking for is speeding up AI and ML algorithm or ML computations and lowering their energy needs. So if we are looking at the graph here, typically our path of development has been from CPU to GPU, FPGA and custom ASIC. So FPGA and custom ASIC basically help, or they let you introduce in the typical von Neumann architectures the concept of AI ML algorithms that we need to kind of have flexibility and changes possible in that. And the next one, which is non-von Neumann architectures, are in-memory computing and neuromorphic computing, which are kind of the state-of-art architectures right now in the market. On the right bottom, you'll find all the use cases where AI accelerator chips are heavily used. And so here we are talking about the journey from the typical GPU to neuromorphic chips that are kind of coming up in the market these days, and they can be understood as existing on architectural spectrum with a trade-off between flexibility in the deep learning models. They can kind of run an efficiency in performing operations. So advances in silicon photonics have all potential to drive improvements in efficiency of all types of chips here. So if you look at the radar chart on the top right here, you can kind of see that this area is progressing quite strongly, except the market momentum. We don't see the market momentum or involvement of that. So probably will take some few years to kind of reach to that. But otherwise, with respect to technological readiness level or commercial impact, defense impact, and so on, that is progressing very strongly. And on the investment charts here, you'll see that the blue line here is the count of investment, number of counts here, and these different colors, which the black especially here that you see is regarding the acquisitions or merger and acquisitions, and what color is if it's purple, then it's private equity funds, or if it's like this teal color, it's early stage, and if it's this yellow color, it's later stage. It means the big players, commercial players are involved, and a lot of funding is going in that area. So this is how you kind of see the investment happening in AI accelerator chips. And these are some companies. Now, by no means I have any kind of interest in these companies, but they are simply exemplars. And these companies have received a good amount of venture capital support or funding, either from private equities or from the federal government and so on. And they are working in different areas to promote or to kind of achieve what we need in AI accelerator chips. For example, the Extropic is working on the full stack approach to generate AI hardware and software grounded in thermodynamic physics and so on. Or Celestial AI is working on photonics fabric, or Encharge is kind of commercializing the usage of AI accelerator chips in commercial applications and so on, and so on. So I won't be going in details about this, but yeah, you can kind of take a look at more details of these companies or startups basically working in this field of AI accelerator. The next field of the next technology that is of interest is alternative position, navigation, and timing. So basically, this technology focuses on the suite of technologies which are used to supplement, enhance, or even replace the existing GPS systems. Why is that needed? Any guess? Any thought from the audience? Why do we have to replace the existing GPS system? I'm sorry? Absolutely, because we depend on the we technologically depend on other countries, and they can really misguide or at one point you may not be able to use it at all, right? So and this is not good for especially the defense sector of any nation, and hence a lot of work is being done in the alternative position and navigation timing. So here, if you look at the what we are looking for is the better timing elements that can really impact missions in both relative and absolute PNT systems. So we have two different kinds of systems right now, the relative and absolute PNT systems, and under GPS denied conditions, we can kind of use it. So if you look at the diagram here, the first one, that is the current state of art onboard inertial navigation units. So here we basically say the intended target is the star that you see here, and this is where a missile, if it's fired from this airplane, will reach on the region on the right hand side, this elliptical region that we see here, right? So if we think of the next gen atomic clocks involved here, we see that this region gets a little bit minimized. And the third one is the fusion of the inertial navigation and the next gen atomic clocks and LEO satellite signals. So if we have combination of all these of them, then it's like this one. So this seems like the story of Arjun from Mahabharata, right? When he was asked, what can you see? You can just see the target, that's all. So this is possible with help of combination of these technologies or these developments in this field of PNT. So you can take a look at the radar chart here, which talks about, or which kind of expresses the status with respect to all those 5 factors we talked about in radar charts, TRL or commercial impact and so on. And with respect to the funding, the PNT investment chart on the right hand side, we see that there's a huge dip and somewhere to 2022 and so on, because of the cut down on rate of interest and because of the rate of interest and so on. We see that dip at that particular 1 year place out there. And these are the use cases. They are typically useful in autonomous vehicles, underwater vehicles, spacecraft, commercial vehicles, and so on. So, 5 more minutes. Oh, okay. So I'll try to just rush through some of them. Yeah, generative AI software development. So in this case, use generative AI to improve coding efficiencies, code generation and completion, code documentation, legacy code conversion and software testing and debugging efforts. And the process of training development of software using generative tools is shown here, wherein we can kind of train with help of training data and use input as a desired coding function in natural language, and kind of use the code snippet for documentation or legacy language and so on, and produce the generative AI software development. So I'm moving a little bit off my track now here. Now, this is quite interesting because I I used to work in the defense sector as a senior scientist. So in spite of that, you are as a responsibility, you are heavily involved in coding. I would say heavily involved in full stack development. And for somebody like us, this is a great peace of mind to have generative AI software development, where we don't really have to sit and do all the nitty-gritty things involved in code development. So these are a few companies working on generative AI software development, the startups with a lot of funding. And here, for example, Hugging Face provides a complete suite of building AI ML algorithms, all the possible tools you need. Also, they have something called as chatbot, wherein they can have some live help given to you if you have any questions and while you're building the AI kind of system. So high density energy storage. So I'll just quickly use a one-liner here. So this works basically for optimizing the energy to weight and energy to volume ratios of energy systems. So how can we have that? And these are the use cases you see on the bottom. And I'll quickly come back to my area of research or problem that I was working on. The next one is hypersonics. Technology for testing and production of weapons that achieve hypersonic propulsion. So here, when you think of hypersonic, it means with the 5 times speed, you expect something to go, right? So we're talking about a hypersonic train between Pune and Mumbai that will be reaching in few minutes. Or you can think of just 20-minute ride from Washington DC to New York, or maybe 45 minutes from New York to London. So it's quite possible to go from Delhi to New York for a lunch meeting and come back Delhi the very same day with this. So this figure from defense perspective, you see the missiles here. The topmost hyperbolic is for the ballistic missile. The middle one is hypersonic glide vehicle, which kind of flies at the lower altitude and gives you a lot of flexibility to move and change the path of that, and the hypersonic cruise missile. So I have done some work in this area with one of the defense agencies, and to kind of figure out what is this missile and what could be the possible source of that and so on. Right? And you can take a quick look on the radar charts and investment charts which are sitting there. The next technology is multimodal AI. And multimodal AI in simple language is a kind of focusing on models that can ingest and or output more than one data type. So basically trying to extract information from different formats and different ways of information, combining say audio, visual, video, like PDF files or some spreadsheets and so on. Have information extracted from these different sources of information and produce the and get some intelligence about the system that you are kind of interested in. Yeah. So yeah. This is about the multimodal AI, and pretty kind of established in terms of the factors that we look in radar charts here, and a lot of huge investment also being seen here in this, especially on the later stage of later stage venture capitalist support is seen here in this area. So this is non-kinetic counter UAS, unmanned aerial systems. So trying to kind of focus on disabling small or medium-sized drones or a group of drones by using effective RF jamming, cyber takeover, or directed energy. So I have done a little bit of work in this to understand what are those elements coming and what kind of I mean, what is the drone that you are seeing? Is it a friend or foe? And how can we kind of take care of that? So there are different technologies like high power microwave range, as you see here, that can control within certain region, or high energy laser technology that can be used for the nearer ones. So with DRDO, I remember working on a project where we were trying to have not related exactly to this, but to be able to have processing of information done by aerial vehicle on the fly to understand what exactly is the element object that you're trying to see, and have computations done on the board. So which kind of has mixture of multiple technologies we have seen here as of now. and yes, few companies working on this non-kinetic counter UAS in commercial as well as in the defense areas. So we see the market momentum is still quite behind, and huge funding is coming here and so on. So yeah, post-quantum cryptography is the next area of technology here, and this focuses on math algorithms, secure math algorithms against attacks by current or future quantum computers, right? So we are here right now. There are a lot of work done by different companies in this area, but it has not come out as a complete product because still everybody is waiting for NIST to release the official PQC standards. So once the PQC standards are kind of generated, then they can be incorporated in the products, and they can be commercialized or used by private and defense sector agencies. So you can see the use cases here, and here what would be of interest is new mathematical algorithms for public encryption. They must be defined and implemented today to resist attacks from quantum computers in the future, in coming years. So these are a few companies which are kind of working on with specific areas of interest in PQC, and these are the for example, if I have to quickly talk about this, Quantum Exchange is working on cryptographic auditing or risk assessment kind of area, crypto agility and crypto diversification area. So they are experts in that, and for example, American Binary or this company is working on quantum resistant cloud infrastructure solutions to critical defense and structural verticals and so on. The next one is space domain awareness tech, and the space domain awareness tech enables an understanding of the space operating environment and perceived threats. So it allows commercial operators to safely fly their spacecraft, avoid debris, and maintain the original regimes they use. So if you look in the chart here, this chart, it kind of shows the objects in the space. So the black color is inactive, and the bluish color is active spacecraft and satellites. So if you see from 2012 to 2022, almost the blue color is constant. The active spacecraft and satellite presence is almost same, but you see increase in the black space here, which is kind of inactive debris and rocket bodies. So how can we, so areas of problems, or areas of research here are, how can we find out these inactive debris and how we can avoid if you are navigating through these space agencies. Okay, and these are a few space domain awareness technologies companies. Some are working on identifying the debris and so on. Some are navigating, finding out the best path for the spacecrafts to move on, and so. And the last one is autonomous swarms. So basically this focuses on a group of autonomous robots that operate as a cohesive unit to perform mission inspired by self-organizing, non-hierarchical biological systems. And the diagram that I talked about, the reliability of unmanned ground vehicles, was basically a decentralized semi-autonomous network wherein we are trying to have placement of these vehicles on the fly. They can on the fly decide what is the best, most optimal way of organizing and carrying out the mission, target mission, and so on. Yeah. So these are the use cases you see on the right, and I guess, and these are the applications you can see in the field of agriculture or emergency management during the fire and so on, or in the entertainment. If you go to Disney park or parks, you see these nice pictures shown in the sky with LED drones flying on the sky. So this is all I kind of would like to do now. Sorry, couldn't come down to the technical work with the different areas. This is what I was thinking to go beyond this, but maybe some other time. Thank you very much, and would also like to wrap up this session by thanking the ACM India team for letting me talk. Would also highly recommend ACMW chapters. Please do form if you don't have in your own colleges, and try to have some kind of collaboration done with other chapters from other regions, and kind of share the experiences of people from different regions. Yeah, thank you very much.
Thank you, Arati, for